Now for this problem, we're going to take a look at this series in the sum from n equals 1 to infinity of 3 to the n plus 1 minus 1 over 6 to the n minus 1 and determine if this converges or diverges. If it converges, we will evaluate the sum. The key fact that we will need to know for this problem is the formula for a geometric series, an infinite geometric series. Summation n equals 1 to infinity of a to the r to the a times r to the n minus 1. If I try to write this out, it would start off a times r to the 0 plus a times r to the first plus a times r to the 3 minus 1 is 2, then a to the 4 minus 1. There is an explicit formula for this that we derived in class. This is equal to a over 1 minus r, and it converges if the absolute value of the common ratio is less than 1, and it diverges otherwise. So that's the key fact that we'll need to use for this problem. Now, in the problem that's given to us, summation n equals 1 to infinity, 3 to the n plus 1 minus 1 over 6 to the n minus 1. This is not exactly set up like this, but it's close. So the way that I will approach this problem is to split this up into two pieces. Summation n equals 1 to infinity, and we will split the fraction up into two. 3 to the n plus 1 over 6 to the n minus 1 minus 1 over 6 to the n minus 1. And then one of our properties of series says that I can break this up if it converges. Summation n equals 1 to infinity, 3 to the n plus 1 over 6 to the n minus 1. And then the second term would be minus summation n equals 1 to infinity, 1 over 6 to the n minus 1. Okay, so I need to evaluate this sum in black separately, and then I'll separately evaluate the one in pink. Now, as it turns out, the one in pink is easiest, so I'll do that first. First, summation n equals 1 to infinity of 1 over 6 to the n minus 1. Now, that is set up perfectly like this. Summation n equals 1 to infinity of 1 times 1/6 to the n minus 1. And so that is set up exactly in this form. My a is 1. My common ratio is 1/6. 1/6 is between -1 and 1. And so I can just simply apply the formula. 1 over 1 minus 6. So 1 over 5/6, which is 6/5. And so that's the one in pink. Okay, that's good. Now, second, we will take a look at the initial one term here. And there's actually two options for this. Now, I will present both options in this video. For exam purposes, I would not expect both to show both of these, but for the sake of the review, I want to show you both of these things. Okay, first, let's take a look at summation n equals 1 to infinity of 3 to the n plus 1 over 6 to the n minus 1. Okay, now this is not exactly set up as a geometric series, but it is geometric. Let's take a look at what happens if I plug in terms. If n is equal to 1, I get 3 squared over 6 to the 0. If I plug in 2, I get 3 to the third over 6 to the first. If I plug in 2, I would get 3 to the, plug in 3, pardon me. If I plug in 3, I get 3 to the fourth over 6 to the 3 minus 1, which is 2. Let me go one more. If I plug in 4, I get 3 to the 4 plus 1 is 3 to the fifth. If I plug in 4 in the bottom, I get 6 to the third. Now, the numerical values of these things are not particularly important for the purposes of this problem. What is important is that if I go from one term to the next, I am multiplying by 3 on top, and I am also multiplying by 6 in the denominator. So to go from this term to this term, I am multiplying by 3/6. And so I see that my first term of this series is equal to 3 squared over 6 to the 0, and that's equal to 9. I also see that I have a common ratio of 3/6, which is equal to 1/2. And so this is a geometric series, not necessarily exactly in the form of a geometric series, but it is a geometric series. And so I can use my formula, a over 1 minus r. So over here I have 9 over 1 minus a half. And so that's equal to 9 divided by a half, and 9 divided by a half is 9 times 2 is 18. Okay, so for the purposes of an exam, once I figure this is 18, I can plug in 18 minus 6/5 and get my answer. All right, now for the sake of the review, I want to show a second way of being able to look at this. Summation n equals 1 to infinity, 3 to the n plus 1 over 6 to the n minus 1. As stated, this does not have the exact form here where I have one thing being raised to the n minus 1 power. So the technique that I will use here is that I will force it to have the n minus 1 power. Okay, now obviously I can't just go from here to here. I had a plus 1 here. I now have a minus 1. So now I have to add 2 to the numerator to compensate. And so now the first line is the same as this. The first expression is now the same as the second expression. I will now use the laws of exponents. That's equal to 3 squared times 3 to the n minus 1 over 6 to the n minus 1. That is equal to summation n equals 1 to infinity. 3 squared is 9, and then I have one thing, 3/6 to the n minus 1 power, which I could simplify as summation n equals 1 to infinity of 9 times a half to the n minus 1. And so this, I now have this set up exactly in the form of a geometric series. And so that's 9 over 1 minus a half, and that's equal to 9 over a half, which is 18 as before. And so either way, by writing out terms like this, or by manipulating the sum, I can see that that first sum is equal to 18. Okay, so I've got the two parts together, and so now I can conclude. So finally, we have that the summation of n equals 1 to infinity of 3 to the n plus 1 minus 1 over 6 to the n minus 1. Okay, that's going to be equal to the first sum, which I just got done showing was equal to 18, minus the second sum in pink way up here. That second sum in pink is equal to 6/5. And so that's equal to 90 minus 6 over 5, which is equal to 84 over 5. So there's the answer. And so I conclude that the series does indeed converge. And not only does it converge, but I found the value of the sum.